The James Webb Space Telescope, humanity's most powerful observatory ever built, is transforming the way we explore the universe. With its extraordinary sensitivity, it has begun revealing details about distant worlds that were once beyond our reach. Among the most fascinating of these worlds is Proxima Centauri b, the closest known exoplanet to Earth, located just over 4 light-years away. Because of its proximity and its position within the habitable zone of its star, Proxima Centauri b has become one of the most intriguing places in the search for extraterrestrial life. Scientists have long wondered whether this nearby planet could possess the conditions needed for life to emerge. Every new observation brings us one step closer to answering one of humanity's oldest questions: are we alone? Recent observations have fueled fresh discussions about this mysterious world. Although no confirmed signs of alien technology have been detected, subtle variations in infrared signals have encouraged astronomers to continue studying the planet with increasing precision. These observations are not proof of intelligent life, but they remind us how much remains unknown about worlds beyond our solar system. Proxima Centauri b orbits Proxima Centauri, a small red dwarf star that belongs to the Alpha Centauri system. Unlike our Sun, red dwarfs are cooler and smaller, yet they are often far more active, producing powerful stellar flares capable of bombarding nearby planets with intense radiation. Despite these challenges, researchers believe the planet may still have retained an atmosphere under the right conditions. If a protective atmosphere exists, it could shield the surface from harmful radiation and potentially allow liquid water to survive in certain regions. That possibility alone makes the planet one of the most exciting targets in modern astronomy. One of the greatest strengths of the James Webb Space Telescope is its ability to analyze the atmospheres of distant planets. By studying how starlight changes as it passes through an atmosphere, scientists can identify molecules such as water vapor, carbon dioxide, methane, and other gases that may reveal clues about a planet's environment. These chemical fingerprints do not automatically indicate life, but certain combinations can provide valuable hints. On Earth, methane is produced by both natural geological processes and living organisms. Detecting methane on another planet would therefore raise important questions, though it would never be enough on its own to prove biology or advanced civilizations. Researchers are also exploring whether future telescopes might eventually detect large-scale technological activity on distant worlds. Some scientists have proposed searching for artificial illumination, industrial pollution, or powerful laser emissions as possible technosignatures. At present, however, no telescope, including James Webb, has confirmed the existence of any of these signals. The challenge is enormous. A planet is billions of times fainter than the star it orbits, making direct observation incredibly difficult. Advanced instruments must carefully separate the faint planetary light from the overwhelming brightness of its host star. Future observatories are expected to push these limits even further. NASA's proposed Habitable Worlds Observatory aims to directly image Earth-like planets around nearby stars. Concepts such as the starshade would block a star's light before it even reaches a telescope, allowing astronomers to observe faint planets with unprecedented clarity. Ground-based observatories will also play a major role. The extremely large telescope, currently under construction in Chile, will feature a mirror nearly 40 meters across and advanced adaptive optics capable of studying nearby exoplanets in remarkable detail. Together with future space missions, these instruments could dramatically improve our understanding of planets like Proxima Centauri b. If scientists were ever to discover a genuine techno-signature, whether artificial lighting, industrial chemicals, or engineered radio or laser signals, it would become one of the most significant discoveries in human history. Such evidence would fundamentally change our understanding of life in the universe. For now, though, the search continues with patience and scientific rigor. Every observation, every spectrum, and every new dataset brings us closer to understanding these distant worlds. Even when discoveries raise more questions than answers, they expand the boundaries of human knowledge. Perhaps somewhere around Proxima Centauri, there is a world unlike anything we have imagined. Whether it is barren, covered by oceans, or home to unfamiliar forms of life remains unknown. The excitement lies not in claiming extraordinary discoveries before the evidence exists, but in knowing that humanity finally possesses the tools capable of searching for them. The universe still holds countless mysteries waiting to be uncovered. As our telescopes become more powerful and our understanding grows deeper, each new discovery reminds us that the next great revelation may be closer than we ever imagined. Until then, Proxima Centauri b remains one of the most compelling destinations in our quest to find life beyond Earth. If evidence of intelligent life were ever confirmed on a nearby planet like Proxima Centauri b, the discovery would reshape nearly every field of human knowledge. Astronomy would no longer be the only discipline involved. Biologists, chemists, linguists, philosophers, historians, and engineers would all face questions humanity has never had to answer before. The first priority would not be communication but verification. Scientists around the world would analyze every observation repeatedly, searching for alternative explanations. Independent observatories would attempt to reproduce the findings using different instruments and different wavelengths of light. Only after years of consistent evidence would the scientific community begin to accept that the signals were truly artificial. If the observations continued to hold up, researchers would try to understand what kind of civilization could produce them. Are the lights concentrated in specific regions, suggesting cities? Do they brighten and dim according to a regular cycle? Are they powered by technologies we recognize or by energy sources completely unfamiliar to us? A civilization living around a red dwarf star would likely evolve under conditions very different from those on Earth. Proxima Centauri emits frequent stellar flares capable of flooding nearby planets with intense radiation. To survive, life there might have developed underground, beneath thick layers of rock or ice, where natural shielding provides protection from the star's violent outbursts. Their architecture, if it exists, could be almost unrecognizable. Instead of towering skyscrapers, they might build vast underground networks illuminated by artificial light. Massive energy systems could transport power across the planet's permanently dark hemisphere, creating patterns that advanced telescopes might someday detect from across interstellar space. Energy production on such a world would also be fascinating to study. Solar power may still play an important role on the day side, but civilizations could also rely on geothermal energy, nuclear fusion, or technologies beyond our current understanding. If they have mastered efficient energy distribution, even subtle heat signatures might eventually reveal aspects of their infrastructure. Communication presents another enormous challenge. Radio signals travel at the speed of light, yet Proxima Centauri lies more than 4 light-years away. A single message would take over 4 years to arrive, and another 4 years for a reply. Even under ideal circumstances, a simple exchange of greetings would span nearly a decade. Because of these delays, any conversation between civilizations would require extraordinary patience. Instead of real-time dialogue, communication would resemble exchanging messages across generations. Every transmission would need to be carefully designed, carrying as much information as possible while minimizing ambiguity. Scientists have long debated what humanity's first message should contain. Mathematics is often considered the universal language because physical laws appear to be the same throughout the universe. Prime numbers, geometric relationships, and fundamental constants could provide a common starting point before progressing to more complex information about chemistry, biology, or our solar system. Some experts argue that we should actively send messages into space, while others recommend caution. Revealing our location to an unknown civilization carries uncertainties that cannot be ignored. Although there is no evidence that extraterrestrial intelligence poses any threat, the consequences of contact are impossible to predict, making the debate both scientific and philosophical. Meanwhile, new generations of observatories continue pushing the limits of discovery. More powerful space telescopes, larger ground-based observatories, and increasingly sophisticated data analysis powered by artificial intelligence are enabling astronomers to identify weaker and more distant signals than ever before. Machine learning systems are becoming particularly valuable because they can examine enormous datasets far faster than humans. These algorithms search for tiny patterns that might otherwise remain hidden, helping researchers distinguish between instrument noise, natural astrophysical events, and potentially unusual phenomena worthy of further investigation. Even if no artificial civilization is found around Proxima Centauri b, the search itself has tremendous value. Every observation improves our understanding of planetary atmospheres, climate systems, magnetic fields, and the conditions necessary for life. Each new discovery refines future missions and brings us closer to answering one of humanity's oldest questions. For now, the nearest known potentially habitable world remains an object of intense scientific curiosity rather than confirmed extraterrestrial activity. The mystery continues to inspire researchers, engineers, and dreamers alike. Whether the first evidence of alien intelligence comes from Proxima Centauri b or another distant planet, one thing is certain. The moment it happens, our understanding of the universe, and of ourselves, will change forever.